You'd be surprised at how many people still don't know about JWST, James Webb Telescope. A lot of people still don't know about it. So I figured we'd do a little quick refresher for some people with a video, something like this. This one here is James Webb Telescope just observed city lights 7 trillion, I was about to say million, 7 trillion miles away. All right, let's check it out. Here we go.
Have found a terrestrial planet orbiting Proxima Centauri. It's the nearest exoplanet we will ever found because it's the nearest star to the Sun.
An unexpected discovery made by the James Webb Telescope. City lights in space, located 7 trillion miles away from Earth. This remarkable finding has sparked curiosity about the possibility of extraterrestrial life. The telescope focused on Proxima Centauri B, the closest exoplanet to Earth, revealing unusual bright lights emanating from it. What could be the cause of these city lights on Proxima Centauri B? Could this indicate the presence of life beyond our planet? Join us as we delve into how the James Webb Telescope detected these extraordinary objects in space. Webb Telescope just caught city lights in the closest star to Earth. For years now, scientists and humans at large have waited and researched to get a glimpse of life beyond our solar system. Any evidence perceived to back up this space fantasy has been welcomed with open arms over time. Recently, the scientific community received the shock of their life when solid evidence of life forms existing in space were observed by the James Webb Space Telescope. While scouting outer space and reporting vital information back to Earth, the James Webb Space Telescope noticed strange city lights shining from the exoplanet, Proxima Centauri B. These lights were just as its name implied, lights looking like they lit up a distant city. The possibility of an alien city existing on the star has left scientists reeling in wonder. Every one of them is baffled, because it seems like this is the existence they've all been waiting for.
What if we do discover something, right? And we get there and it's a complete mirror image of what we're doing and what we look like and what's going on here on this planet. Sort of like a parallel, a complete mirror image. They have the United States, they have Africa, they have Asia, they have everything. The exact same way we have it here, they have it there. That would be crazy.
If this turns out to be true, as everyone thinks it is, it means that there are intelligent life forms organizing civilizations foreign to what humans know in outer space, and we're only just discovering it. Peering into the city lights that are located 7 trillion miles from the Earth, NASA engineers can't help but wonder how long these lights have shone in space, waiting for humans to grow the required technology to detect them. David Kipping, an astronomer from Columbia University, describes the Proxima B exoplanet where the city lights were found as tricky. He said so because this star system nearest to us has varied heating patterns that aren't similar to other planets. The usual rocky planets are known to take in sunlight and emit infrared radiation. Not so for this exoplanet, as its infrared nature is quite different from that of its host star named Proxima Centauri. This makes for a good observation by the James Webb Space Telescope, JWST, and the telescope came in handy as the right tool for the job. The JWST is able to easily detect infrared wavelengths. The distinct heat signature of Proxima B will play a great role in discovering the universal secrets of its atmosphere. And that'll be done because of the latest technology of infrared imaging capabilities possessed by the JWST. Scientists plan on using the telescope to reveal the mysteries surrounding this planet at atmospheric components. They also aim to use the Webb telescope to assess the possibilities of residing in this exoplanet. James Webb Telescope has an infrared sensitivity that's poised to explore what happens at Proxima Centauri B's nighttime. Picking up the faintest rays of light in the cosmic darkness is usually a struggle for space telescopes, but not for the JWST, as it can pick out even the tiniest rays of light from space. It's the perfect instrument to verify if the rumors of city lights on Proxima B night side are true or not. Every artificial illumination in the cosmos can be sensed by the telescope, as long as it falls within a frequency band that's 1,000 times narrower than the starlight. Proxima B has an interesting relationship between its stellar features and surface interactions. The day side of the exoplanet contains many solar panels that harness the bubbling radiant energy possessed by the star. Its spectra edge also reflects incoming light rays at the same time. When Proxima B completes its orbit around its host star, Proxima Centauri, it experiences day and night periods, similar to what we have on Earth, with the daytime getting high on solar heat and the evening experiencing coolness.
Right.
The planet is known to have temperature fluctuations that are determined by its composition. For example, if there's no atmosphere in Proxima B, the difference between its day and night periods will be wide and far between. If there's no moderating influence of atmospheric gases and oceans, the temperature of the day side will be so hot like a black body, and the night side will horribly drop into cold darkness. The degree of temperature variation is a good subject for astronomers to unravel a deeper understanding of Proxima's atmospheric composition.
I know like a lot of people would be like, well, how is that possible? How would life be able to survive if it were like that? Where if it's no atmosphere, then the day and night is so far away from each other that days could be so hot and night could be extremely difficult temperatures, cold temperatures to deal with. You always got to keep in mind, man, the ability for life to adapt. That's what I always hang my hat on when I think about certain planets, or I think about, or I hear the information about certain planets, and you be like, man, those atmospheres, man, those gases, man, those temperatures, this, that, and the third. Life will find a way, man. Life will find a way, and it will adapt. As scary as it may be, it'll find a way.
Having an unrivaled infrared imaging capability, the JWST can efficiently examine the planet's thermal emissions to provide insightful data about its atmospheric properties. Interestingly, the orbit of the James Webb Telescope around the Earth falls in alignment with Proxima B's orbital period, making complete observations of its day and night periods within 11.2 Earth days. Since it indeed has an atmosphere, the next step will be to assess its atmospheric chemistry to determine if it can accommodate life. Some good pointers in determining if there's life is the presence of gases like oxygen, water, vapor, and methane. If these elements can be found on the planet, it means that it supports habitable conditions. The process of successfully determining this requires scientists to be meticulous enough as they capture and examine light rays that move through the planet's atmosphere. This is a very challenging task to undertake. Even if the JWST possesses great capabilities for characterizing planetary atmosphere, it has a different major objective. The telescope has been customized to only analyze the variations in water vapor, carbon dioxide, and methane concentration. When it comes to identifying bonded oxygen, which is a vital indicator of life, the JWST is limited in this area. Even at that, the telescope still has valid reasons to search for other elements on the planet, such as ozone, which gives away an accurate level of vitality in the atmosphere. It's also worth of note to mention that the James Webb Space Telescope doesn't have absolute capabilities, and it can only peer at a few of the closest habitable worlds to Earth. Carrying out a thorough atmospheric investigation, astronomers are now tilting toward ground-based observatories like the Extremely Large Telescope, fondly referred to as ELT. The ELT is a telescope that has been scheduled to start operating in 2028, and it's carefully positioned to gaze deeper into the atmospheric structure of faraway exoplanets. It'll produce data on these planets that'll offer comprehensive and vivid insight into their level of habitability. NASA scientists and everyone are happily waiting for the deployment of future space telescopes like these. Until then, however, the James Webb Space Telescope remains a vital tool in our quest to uncover the mysteries of distant exoplanets.
And it's more than equipped.
Even with its current limitations, the Webb Telescope has the potential to offer deep insights that will revolutionize our understanding of exoplanetary exploration now and in the future.
Facts.
Scientists have an objective for future space telescopes, and that is to reduce the amount of bright light coming from a planet's host star so that astronomers can better see the lights reflected from a planet itself. They plan to do this by using internal masks, or gigantic external satellites that are shaped like an umbrella, similar to using your hand to block out rays of the sun to enable you to see an object clearer. Reducing the fierce brightness coming from the host star, future telescopes will be better positioned to study faint reflections of light coming from a distant exoplanet, allowing for vivid analysis of its atmosphere and likelihood of supporting life. Doing this comes with its own challenges, however. Scientists will have to differentiate between gases generated from life and those from geological processes such as volcanic activity.
How are you gonna do that?
Astronomers aren't giving up on understanding the characteristics of exoplanets, so they're more able to spot signs of life and distinguish them from false positives. The Webb telescope contains a preview of scientific advancements from the research of exoplanets, offering a sneak peek into the amazing discoveries we're yet to find. As we stretch our understanding and exploration of the cosmos farther and farther, we're better positioned to understand the intricate workings of the universe and our various roles in it. After searching through all the planets in space, scientists have yet to find anyone that hosts life. Despite decades of searching through space for signs of life, the quest for forms of life on other planets continues. Are we alone in the universe? For millions of years throughout human civilizations, humans have always wondered whether they are the only ones in the universe. This is an age-old longing that still hasn't left us in this present time. Even now, scientists have the James Webb Telescope in outer space, trying to spot alien civilizations hidden amongst us, while studying all kinds of planetary bodies for signs of life at the same time. A popular narrative has spread in recent times that some aliens are truly out there in the stars, just waiting for humans to find them. To provide an answer to this question, two American astronomers, Jill Tarter and Thomas Pearson, started a project called Search for Extraterrestrial Intelligence in 1984, known as the SETI Institute. It is a non-profit venture that plans to sift through cosmic signals to pick up only radio signals from space. The reason for focusing on radio signals is because of their ability to travel through long distances without getting scattered or absorbed like other types of radiation. Due to this characteristic, radio signals are more likely to be detected by the 42 radio telescopes that constitute...
And we've been doing this since '84, right? So y'all don't think there's a possibility we came across any signal? Besides the wow signal, the famous wow signal we always talk about. But we don't think we've come across any signal that may suggest other life? All these years, decades? Come on now.
the Stellar Allen Telescope Array, found in the Cascade Mountains of California. Though the SETI Institute has religiously observed signs of these radio signals generated by alien life, there haven't been any such signals for over 30 years.
I don't believe that.
Jill Tarter is enthusiastic that they'll have a positive result, as they want to use the tools of the 21st century to accelerate the search. In the words of Jill, "I wish that you would empower Earthlings everywhere to become active participants in the ultimate search for cosmic company." All of that continued until recent reports from NASA implied that the James Webb Space Telescope spotted city lights from a planet close to the Earth. The JWST is the giant trump card played by humans in getting a finite grasp of the universe. It's currently the most advanced instrument in all of mankind to unearth all the mysteries of the universe. The telescope is currently floating about 1 million miles away from the Earth, sending accurate details about the earliest periods of the universe. It's designed to capture the previously elusive facts about space, as it delivers greater clarity on the formation of space galaxies, planets, and stars alike. Astronomers haven't failed to capitalize on the JWST's cutting-edge technologies, such as its stellar camera feature, and filters to spot and analyze the delicate colors that surround celestial objects. Researchers are comfortable using the telescope to collect data about the physical properties and chemical compositions of celestial bodies located far away in the cosmos. This was achieved by isolating specific wavelengths of light. Far beyond just observing, the Webb telescope continuously gazes upon the atmosphere of exoplanets for faint traces of life, no matter how little. It has an unrivaled power to analyze the power of time and space, and has exposed some of the most intriguing findings ever. One such is the discovery of more mass than what was previously believed to have existed in the universe. This mass has been stashed away in several giant galaxies, effectively casting doubt about the earliest layout and proportions of the universe. Humanity has since set out to explore the farthest reaches of the cosmic plane, using the JWST as an integral tool for achieving this. Through the telescope, new information on isolated worlds will be documented, and more astrophysical information will be available to solve the mysteries of these planets. 20 years ago, the cosmic realm outside our solar system wasn't explored. Since that time, however, astronomers have identified over 4,000 exoplanets that orbit distant stars, showing just how far human ingenuity can go. Still, all of these discoveries are regarded by NASA as just touching the tip of the celestial iceberg. Scientists are of the opinion that in reality, there are trillions of exoplanets littered all over the cosmos that haven't been discovered yet. Not giving up over the decades.
So basically, a strong possibility we won't find nothing during our lifetime, y'all. If you're around my age, maybe the babies that are being born right now may have a shot and opportunity, but man.
Scientists are still exploring space in hopes of fishing out alien habitats in places where humans haven't ventured. They've had glimmers of hope during this quest from time to time. When Galileo hopped on a spacecraft traveling to Jupiter, its spectroscopic instrument unknowingly revealed a unique spectral signature that lent credence to extraterrestrial vegetation. This was the first time scientists found a biosignature that indicated the presence of life in the cosmos. This biosignature was the vegetation red edge, known as VRE. The VRE hunts down alien life differently by paying close attention to the way it reflects light. With the help of the VRE, the James Webb Space Telescope is expected to uncover the riddles of extraterrestrial environments through the meticulous mapping of orbital parameters of potentially habitable planets resident in the habitable zones of their alien parent stars. Once these are detected, the VRE can present crucial evidence in the search for intelligent life forms outside the Earth, unlocking a fresh journey in unveiling the mysteries of the universe. When sunlight passes through the atmospheric layers, the disintegrated light, which bears with it different wavelengths, gets absorbed by the atoms and molecules found in these layers. As the absorption continues, a distinct spectral pattern that's akin to exclusive fingerprints is formed that can be deciphered through spectroscopic analysis. It's a common theory that when light from stars gets to a planet, the Webb telescope will be able to detect it as it enters the planet's atmosphere. This knowledge suggests that the JWST could be the missing link to unveiling the atmospheric composition of these planets. Planets that are the size of the Earth contain atmospheres that are rich in carbon dioxide, nitrogen, and oxygen. Though these kinds of planets might be able to host life, the lack of unusual compounds could point to alternative forms of life and technological civilizations. Compounds like chlorofluorocarbons, known as CFCs, are man-made compounds used for refrigeration and other industrial purposes, and could help scientists prove the existence of extraterrestrial civilization beyond reasonable doubt. If the JWST as much as finds...
Stop putting our parameters on them. They may not require all of that and be just fine. We gotta stop doing that.
Such artificial molecules in the atmosphere of exoplanets, it'll be an undeniable proof of extraterrestrial activity beyond our solar system. This opens up a new window for cosmic researchers to understudy the atmospheric compositions of other worlds and the slight probability of alien civilizations over and beyond the Milky Way. Life away from the Earth is characterized by many possibilities that transcend the limitations of earthly biology. While we always think of life as flourishing in temperate climates, the reality of life could be a little more extreme and complex. For instance, Extremophiles, an intriguing group of organisms mainly composed of bacteria, challenge all that we've come to know as a suitable habitat for life. These cheery life organisms effortlessly survive and blossom in conditions that we regard as extremely severe. Extremophiles can live in and adapt to even the most horrific environments of temperatures that are up to 250 degrees Fahrenheit and pH levels below 3. The presence of these organisms are a prime example of the durability of living things surviving under the most difficult conditions.
Life finds
Due to
a
this,
way.
the unlimited dimensions and innumerable environments that come with it reveal to us that our search for extraterrestrial life has no choice but to be extensive. These planets that look like the Earth and orbit around stable stars that resemble the Sun make for good research opportunities. Nevertheless, thinking of alternative scenarios for exploration, such as the exoplanets that move around red dwarf stars that are so numerous in the universe. Though these red dwarf stars are not anything as bright as our Sun, plus their temperatures are generally cooler, these stars are present to afford us unique opportunities to investigate the possibility of life in varied environments. The extended lifespan of red dwarf stars provided lots of opportunities for the slow, complex processes of life's serious evolution to unfold. One major unfolding is the James Webb Space Telescope's discovery of a new planetary system called the TRAPPIST-1. The best part is that the planets inside this system look like Earth and might support life. Planets resembling Earth in TRAPPIST-1 planetary system. The planetary system referred to as TRAPPIST-1 consists of a dimly lit red dwarf star along with 7 rocky planets similar to Earth orbiting the red dwarf star. Among these 7, 3 of these planets have been discovered to be habitable planets and are likely to have liquid water on their surfaces. Though it might be smaller and cooler than the Earth's sun, the TRAPPIST-1 star gives off a soft light that's similar to those being emitted from the Earth. Scientists picked apart the light coming off from the star's usual light, as it could help in the hunt for habitable conditions in the amazing planetary TRAPPIST-1 system. Studying the entire planetary system, the JWST had deduced that the red dwarf star is likely 41 light-years away from Earth in the constellation Leo. Happy about this development, Ward Howard, a research lead author and NASA Sagan Fellow at the University of Colorado Boulder, was heard saying that because of JWST, it is the first time in history we've been able to look for planets around other stars that have the sorts of secondary atmosphere you could find around. He also said that if you want to understand exoplanets, it's really important to understand their stars. There are so many stars scattered around the cosmos, but one that stands out is Proxima Centauri, because it stands out as an embodiment of potential from a distance of 4.25 light-years from the Sun. That's why it is commonly referred to as the closest star to the Earth. The appearance of this star can be observed in its faint glow. It is hardly noticeable through the darkness of the night sky from Earth. The poor luminosity signaled that any habitable planets orbiting the star must maintain the distance of many habitable planets of Proxima Centauri and must be around 20 times nearer than Earth to the Sun. If these conditions are not met, none of its planets can sustain habitable conditions like our planet. On August 24, 2016, astronomers made an interesting revelation and discovered a planet that came with 1.3 times the mass of Earth. It was residing within the habitable zone of Proxima Centauri. This region was Goldilocks and offers a fragile balance of light intensity since it's perfectly positioned to melt ice for water and potentially water the seeds of life. Proxima B is a paradoxical exoplanet that orbits around its host star named Proxima Centauri. The planet, which is just 4.6 million miles away from its little red star, has several situations that threaten to overthrow its ability to sustain life. Being close to its host star, Proxima Centauri B exposes the star to great solar winds, which can eat away at its atmosphere. Not minding all of these difficult circumstances, this exoplanet enjoys the sunlight of its tiny star, as it receives enough sunlight to just maintain an Earth-like temperature where the water and liquid will surely form.
That's our problem right there. We think everything gotta be Earth-like. No, it doesn't have to be.
Due to the planet's close orbit, scientists have experienced something called tidal locking, which drives one hemisphere to be subjected to constant, intense sunlight, as the other keeps experiencing complete darkness. It has a semblance to the Moon's relationship with Earth and our solar system. Receiving just 18% of the mass of the Sun, Proxima Centauri gives off a faint glow by emitting far less light than is expected. Proxima Centauri is known to turn conventional expectations on its head and challenge them. In spite of the challenges posed by its close orbit, coupled with the potential loss of its atmosphere to solar winds, the planet provides compelling possibilities. If it has an atmosphere that could store heat, then it would be possible for liquid water to form on the surface. This alone could kickstart the chain of habitable processes taking place in the exoplanet. Little by little, life forms in the water will start undergoing evolution until it spreads out to the beasts of the land, and then the birds of the air. Proxima B only receives 65% of Earth's total solar energy, making its prospects for generating and aiding life very low. The planet's possible state of tidal locking sparks off extreme temperature differences between its scorching daytime and its freezing nighttime. These harsh conditions are made worse by the planet's close position to Proxima Centauri, subjecting Proxima B to intense radiation, including ultraviolet rays and X-rays. These radiation rays don't bode well for the long-term health of the planet. It also makes it inhabitable to life as we know it on Earth. Not to mention that the planet is also constantly bombarded by high-energy particles during solar flare-ups. If the planet doesn't have a significant amount of magnetic field, like those of Earth, all of these bombardments could wear off and strip away its atmosphere, removing the necessary conditions required for life to start thriving there. Realistic projections reveal that tidally locked planets like Proxima B are likely to experience fast atmospheric collapse when volatile gases freeze out at night. For Earth, volcanic activity replenishes the atmosphere, but for this exoplanet, there are no such mechanisms available for the atmosphere to be renewed. The mysteries tied to this exoplanet go deeper than its surface conditions to its decent potential for being home to advanced alien civilizations. With the extreme conditions observed on the planet, it'll not be surprising to later find that aliens that fall into the Extremophiles group secretly live and build alien huts and cities on Proxima B. With the knowledge currently available to humans, there's far little insight into the volcanic activity of Proxima B or the strength of its magnetic field. Notwithstanding, there's a tantalizing possibility of atmosphere fuel speculation about the planet's potential for hosting life. Since there's an atmospheric presence on the planet, however, it means that there's a great potential for the existence of seas. This dramatically raises the prospect of life.
Which I think y'all might find if they have seas or potentially do evolve to where they do have seas, what type of things you think will be in their water? Just thinking about all of the different things that we talk about within our own ocean, imagine what they might have.
And the unending human quest to discover signs of otherworldly civilizations on the planet. This desire to stumble upon alien creatures living their secret life on the planet has intensified over the past few years.
Oh yeah.
Because there are speculations that such creatures could have intensified their superior technological solutions to overcome the inhabitable atmosphere of the exoplanet. These are the wild theories scientists are coming up with for their inability to find alien life after all these years of painstakingly searching for them in space. One of these theories by scientists proposes that aliens use the concept of deploying vast solar panels across the day side of Proxima B, just to avoid the inhospitable conditions of the planet. Scientists with this theory believe that solar panels would harness the energy of the stars to shine bright and warm the continuously dark night side of the planet. Scientists are convinced that doing that could easily transform the bleak landscape into a habitable form capable of supporting life. Discovering Proxima Centauri B has triggered a heated race among astronomers to reveal if it crosses its star's face like it's seen on Earth. These movements easily allow scientists to measure the size and mass of the planet. Later on, they'll also calculate the planet's density and confirm its rocky composition in order to derive valuable insights into the materials that make up its rocks. Also, the starlight that goes through its atmosphere during these movements provides clues about the composition of its habitability and atmosphere. No matter the challenges involved in demystifying Proxima B, the search to analyze the puzzle surrounding this planet remains a priority. As long as humans back on Earth have this insatiable thirst for knowledge about what goes on beyond our solar system, they'll always chase after other life forms outside the Earth. While doing this, Proxima Centauri has a troubling characteristic that rapidly increases the amount of flares it springs up. This just adds another layer of complexity when it comes to investigating a habitable world in one of the exoplanets, like Proxima Centauri B. Nevertheless, the James Webb Space Telescope comes in handy, as it'll keep staying out of reach of these flares, capturing important photos and sights of the cosmos so we can study them better on Earth. What do you think about the artificial city lights detected 7 trillion miles from the Earth on Proxima Centauri B?